Hey everybody, Mr. Murphy here with another lesson video for you. This one is going to be on finding the volume of pyramids and cones. Remember that the volume is when somebody asks you about a three-dimensional object, how much space does it hold, and we measure that in cubic units, so like 1 by 1 by 1 cubes. Okay, in any case, you've already done volume of prisms and cylinders with a formula that looks like this, hopefully anyway. Big B, which stands for base area, times the height, so the height of the actual three-dimensional object. For pyramids and cones, the only difference that we have to do with this formula is that since it is not a full prism with parallel bases, it has one base and it comes to a point, we take a third of the volume that we would have if we had a prism with the same base. Same thing applies to cones. So base area is that capital B. Remember, base area, we change the way we find that based on the shape of the base. And in height, that's just one measurement. It's just the height of the pyramid or cone. Okay. So with this 1/3 base area times height formula, we're going to go ahead and practice finding the volume of a pyramid. So that will look like this. We see our pyramid here. If you look at the base, we want to know what shape that is before we get started. And with all those right angles, I can go ahead and tell that that's a rectangle base at the bottom. And I know I'm going to be doing volume equals 1/3 base area times height. So off to the side here, I'm going to calculate base area. Now, since this is a rectangle, that's very easy. I just need length times width. In other words, 9 times 7, which gives me 63 yards squared for my base area. Then, of course, we need the height that's given to us. That's this 12 yards here. So from the top to the very center of the base at a right angle, that's our height. So that's going to be 12 yards. Cool. So those two numbers we substitute into this volume formula and call it a day. Volume equals 1/3 of 63 times 12. Okay. Alright, now you can multiply all of this in any order. The first example, we're going to multiply the base area times the height first. So that's going to be 63 times 12. So that gives me 1/3 of, when I multiply I get 756. And then last but not least, to get rid of this 1/3, we multiply. Remember, when you multiply by 1/3, you're really dividing that number by 3. So now I'm going to do 756 divided by 3, which gives me a volume of 252 cubic yards, or yards cubed. Cool. So that is the volume of this pyramid. If I had 252 cubes that are 1 yard by 1 yard by 1 yard, I could arrange them and it would fit this pyramid exactly. That's what this answer tells us. Okay, cool. Now, on to number 2. Number 2, we can clearly see is a cone, because we have the circular base. However, the volume formula is still going to be this one. It's just the way we calculate base area will be different than the way we calculated this base area. For a cone, remember the base area, since it's a circle, the formula you have to use to find that is the area of a circle formula. In other words, pi r squared. Thankfully, this measurement here from center to outside, that's our radius, so that's going to be 4 feet. So that's going to be pi times 4 squared, which works out to 16 pi feet squared. Can you see that okay? Yeah, 16 pi feet squared. Alright, good. Now, I'm going to leave this in terms of pi for now. In other words, I'm not going to worry about multiplying pi until the very end of my problem, because that's just going to make my life a little bit easier, and you'll see why. Now, we know that we also need the height of the cone, which is going to be this 12 feet. And then once again, we're just going to substitute into that 1/3 base times height formula. I am going to do this a little bit differently than I did the last one, but still the same thing. Once you have base area, plug that in, so 16 pi. Remember, leave the pi for now. And the height is 12. Cool. Alright, now hopefully on the last example, you heard me say that with this 1/3 and these numbers, we can kind of multiply in any order. Last time we multiplied base area times height first, but on this one, look what happens when you use up the 1/3 first. If I can multiply in any order, and I know that multiplying by 1/3 is just dividing by 3, one way I can make problems simpler for myself is to multiply out of order, like this. For instance, 1/3 times 12. In other words, 12 divided by 3. Now I know 12 is divisible by 3, that gives me 4 times 16 pi. And now the 1/3 is gone. So if you'd rather do that when you notice numbers that you know are divisible by 3, go for it. It can often make the problem a little bit simpler. Now all I have to do is multiply here, 16 pi times 4. 16 times 4 gives me 64 times pi. Cool. And then on certain problems, you can stop here. A lot of times people like their volumes of cones and cylinders expressed in terms of pi. But if your problem says something like round to the nearest tenth or round to the nearest hundredth, that's when you want to go ahead and do this. 3.14, and then actually multiply that. So 64 times 3.14 works out to roughly this much, 200.96. And then remember, this is volume, so we're going to put our answer in cubic feet, or feet cubed. Okay, cool. So that is how you find volumes of pyramids and cones. It is pretty straightforward. Just don't get too thrown off by that 1/3. Remember, multiplying by 1/3 is the same as dividing by 3. Now, with pyramids and cones, there is one sort of layer that prisms do not have. I'm going to show you that right now, but it's all math you have done before, just applied to 3D. So, here we have a square pyramid, and the problem does not explicitly tell us this, but we're going to go ahead and, for the sake of ease, assume that this 10-unit side is the same length as this side. So I'm going to put another 10 over here. That means that all of the sides that form the base of the pyramid are forming a square. Okay, so just like before, I know my formula is volume equals 1/3 capital B for base area times height. Here's the problem. On this example, this measurement that they're giving us, the 13 units, is not the height. The height, if we look at the other two examples, was measured down from the vertex, we call it, of the pyramid, down to the very center of the base at a right angle. Okay. So that presents a little bit of a problem. We don't have the height that we want to solve for the volume. But luckily, because the height always has to make a right angle to the base, that gives us a way to find the height. We have this, what we call, this 13 here, by the way, is called the slant height. And the slant height, plus having the measurements at the base, can help you find the regular height. So the measurement we really need is from here, where the height touches the base, over to here, where the point there meets the slant height. Now, that point is easy to find, because that also makes a right angle with this side, which means if this length is 10, this length is only half of that. So that length would be equal to 5. And if you notice, what we have in the middle there, I'll kind of draw it out here. That's the height. That's the slant height. Here we go. Right angle. And then that line there is a 5. And we have a right triangle, which means if I want to solve for the height, I can do this. 8 squared plus 5 squared equals 13 squared. I can use Pythagorean theorem to find my actual height of the pyramid. So, 8 squared, we don't know. 5 squared we know is 25. 13 squared we know is 169. Subtract the 25. That should leave you with 144. And what number squared equals 144? I take the square root, and that tells me that the height of the pyramid is actually 12. Okay, cool. So that gives you the measurement you need to solve for the volume. So now the height is 12. The other piece we need is base area. Luckily this is a square, so you just treat it like a rectangle. 10 times 10. That gives us a base area of 100. Like so. Same formula. And again, I see that 12 there. I know 12 is divisible by 3. So it's another good opportunity to do 1/3 of 12 first. That gives you 4 times 100. And multiplying by 100 is easy. Just multiply the 1. So that gives you a volume of 400 units cubed, or cubic units. Okay. So with pyramids and cones, if you need to find the height, either just to know what the height is or to find the volume, and all you have is the slant height and the measurements around the base, you can do that. You can use Pythagorean theorem and think of it as a right triangle to help you solve for that. As a bonus, this length will always be the height of your pyramid or cone. This length will always be the slant height of your pyramid or cone. And this length will either be half of the base on a square or rectangular pyramid like that, or on a cone, that length would be the radius of the circle. See the same right triangle thing happening here. Okay. I hope this helps you guys when you are working on the next assignment, finding volume of pyramids and cones. You may still see a couple of volumes of cylinder questions on there, just to give you that heads up. Anyway, hope this helps. Have a great day, and enjoy.